Before we get too far, what do you notice about this data? You notice that this data is going up, and what's happening to the intensity?
It's going down.
Okay, so probably the power regression is going to be an inverse one, okay? But we'll see. We'll see if our exponent's negative. All right, so now that you have your data in there, go to Stat, go on over to Calculate, go on down to A, or whatever yours is at, push Enter. The X list, I've got an H there. I don't want that. I want list 1. Don't ask me why that's on there. Frequency list, fine. And you just want to calculate.
Hey, what did you hit to?
Oh, I'm sorry. Stat, and then go over to calculate.
Oh, and messed up now.
All right, well, check it out. Does everybody get these numbers, pretty much? Hopefully you do.
I don't get an R squared or R.
Okay. Oh, we'll have to turn, you would turn your diagnostics on your calculator on. Yours must keep going off every time you turn it off. But all right, so let's write this equation. You don't have to worry about the R's, but what I want you to worry about is the A and the B. Look at the A. The A is the number in front. That's kind of like our K, all right? And what is our B in this case? A negative 1.99. That's the power, and it is negative. So let's take this and write this equation down. So, to model the data. So, is distance X or Y? It's X. So let's do this. The intensity, which is W over M squared, equals, the intensity equals 7.93 times X to the negative 1.99. That's about.
Is that a W?
Yeah, that's a W. I use these things over there. I use kind of that notation. I guess you could say 2. Now it says to describe, probably with words, people, the relationship between the intensity and the distance modeled. So we would say intensity varies how, guys? No, varies.
Directly.
Nope, you have to use direct or inverse. And because since this is a negative, it varies inversely. And okay, we're going to go.
I only got the word Chelsea.
There you go, the negative 2 right there. So the intensity varies inversely with the square of meters. Okay? Because this also is the same as 7.93 over X squared. Okay? So that's how we know that because the negative moves it down below. And that means that it varies inversely. Does that make sense? Okay. I'm getting no response, so I'm assuming it makes total sense.
Why is it the square meters instead of meters?
Because this right here, even though I put X, it's meters squared.
Oh.
Okay? Because that's the label for X is meters. Okay?
Yep.
Now, use the regression model from part A, this guy right here, to predict the intensity of an object that is 2.75 meters away. So what do I put 2.75 in for right here?
The 7.
I put it in for I or X? X.
No, I don't.
So intensity equals 7.93 divided by 2.75 squared. Or on your calculator you could do 7.93 times 2.75 to the negative 2.
Wait, where did you get the 7.93?
That came up on my calculator.
Okay.
That was my A. All right, so now let's do that. Here we go. Okay, we have 7.93 divided by 2.75 squared. And I get 1.05. And the label for that is W per meters squared. Okay? And does that kind of make sense? 2.75 is in between, and is 1.05 in between those two numbers. Yeah, so your answer makes sense. Okay? All right. Now,